Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to this channel and hit the bell icon to get notified when I post my new videos. Today I'll be discussing how to determine moment of inertia for a circle using method of integration. So here basically I have considered a circle which is having the radius of equal to capital R, and I have also chosen a elementary section, so which is noted as a shaded portion over here. You can just observe here. So it is at the distance of small r from the center, and theta is the angle made by the elementary section with reference to horizontal or the x-axis. And then we have dr is the radial distance or radial width for the elementary section. And then we have g as a overall centroid of the circle, and d theta is the internal angle subtended by the section, that is the elementary section. So by considering this, we are supposed to find out what is the moment of inertia primarily for the elementary section, and then by using that we are going to find out what is the moment of inertia for the circle as a whole. So now we are going to determine what is the moment of inertia for the elementary section. So first of all, I just consider dA as the area of the elementary section, and we know that dA is equal to r times of d theta. So here this shaded portion represents the elementary section, whose width is equal to the arc of the circle. So arc of the circle will be in terms of radius multiplied by the internal angle subtended. So here the radial distance is equal to small r, and d theta is the internal angle subtended. So therefore it is equal to r times of d theta, and then the width is equal to dr. So therefore we know that the area for the elementary section can be taken as r into d theta into dr. So dA is equal to dr into r times of d theta. So after determination of the area of the elementary section, we need to find out what is the moment of inertia for the elementary section. So moment of inertia for the elementary section is nothing but dA times of the perpendicular distance square. So here dA is the area of the elementary section. So here you can just notice a dot over here, so which represents the centroid of the elementary section. So here the centroid of the elementary section can be considered, which is having at the distance at the vertical distance of y from the horizontal axis and x from the horizontal axis. So we know that theta is the angle subtended by the elementary section with reference to the horizontal axis. So therefore I can take y as r times of sine theta and x as r times of cos theta. So therefore, in order to find out the moment of inertia for the elementary section with reference to horizontal axis as a reference, so it is nothing but area into square of the perpendicular distance. So here with reference to horizontal axis, y is the perpendicular distance, so area will be dA. Y is the perpendicular distance, so dA times of y square is the moment of inertia for the elementary section with reference to horizontal axis. So as we know that y is equal to r times of sine theta by the diagram itself, so we also know that dA is nothing but r into d theta into dr. So if we just substitute the equation in the equation, so we'll get it as r d theta into dr, so into y square. Y here is nothing but r sine theta the whole square. So this is all about the determination of moment of inertia for the elementary section with reference to horizontal axis. So with by using the equation for the moment of inertia for the elementary section, so we can find out what is the moment of inertia for the overall section, for the overall circular section. So we know that horizontal axis is taken to be as a reference axis. So therefore Ixx is the moment of inertia with reference to xx axis. So therefore we are supposed to integrate the equation for the moment of inertia what we had obtained for the elementary section. The value limits of the integration is between 0 to 2 pi. 0 to 2 pi is the limit of the integration. So after integrating, we'll get the value as r cube sine square theta dr into d theta. So we know that sine square theta is nothing but 1 minus cos 2 theta divided by 2 dr into d theta. So integration limits is 0 to 2 pi. So after the integration, we'll get integration with reference to theta as theta minus sine 2 theta divided by 2 with limits 0 to 2 pi r cube dr. So here we have two times we need to do the integration. It is a double integration we are supposed to do. So one with reference to d theta and another with reference to r. So therefore with reference to theta, the integration is equal to theta minus sine 2 theta divided by 2 with the limits 0 to 2 pi. So again we are supposed to integrate the same with reference to the limits 0 to r, so that we can integrate the other value of r as r cube dr. We can integrate it easily. So therefore with limits 0 to r, it will be 2 pi r cube dr, 2 pi r cube dr, 2 pi r cube dr. So this 2 pi I have got by this equation, by integration, by integrating that equation and putting the limits between 0 to 2 pi. So if I just integrate and substitute the value between 0 to 2 pi, I'll get the value as half into 2 pi. So after integration, once again we are supposed to integrate between 0 to r cube dr. So integration of r cube will be r to the power of 4 by 4. So within the limit 0 to r, capital R. So therefore after all integration, we will get the value of moment of inertia as pi r power 4 by 4. Pi r power 4 by 4. So here wherein this capital R represents the radius of the overall circle. Radius of the overall circle. I just repeat this procedure once again. So first thing, we are going to determine what is the moment of inertia for the elementary section first, and then the same equation we are supposed to integrate with reference to the limits 0 to 2 pi, because we have the two integration, we have the double integration system over here with reference to theta and with reference to r. So in order to integrate the with reference to theta, we have the limits 0 to 2 pi. In order to integrate the radius dr, we have the limits 0 to capital R. So after integrating with reference to 0 to 2 pi, we are supposed to integrate the equation of r with reference to 0 to capital R. So after all the integration and simplification, we will get the value of Ixx, that is moment of inertia with reference to horizontal axis, as pi r power 4 by 4. And since we know that the circle is a symmetric section, so in all the axes, so Iyy, if we just look at, so it will be also having the same equation as that of Ixx, that is equal to pi r power 4 by 4 itself. So Ixx and Iyy value for the moment of inertia for the circle will remain same, that is pi r power 4 by 4. Thank you for watching. Please like, share and subscribe the video. Thank you.